Hi everyone, this is Prakash Chogle from Top Postal Community. So let's begin with another session of this Laplace Transform. So in the last class I derived some of the common Laplace transforms standard result, and here is one more, that is Laplace transform of one of the important, could be asked, Laplace transform of t power n as n factorial by s power n plus 1, where n is positive integer, that is n can be 1, 2, 3, so on. So then only L of t power n is n factorial by s power n plus 1. So let's try to prove this. From among all the previous proofs, this could be asked in the exam to prove this. So let's, by the definition of Laplace transform, as you know the definition, by the definition of Laplace transform, how L of f of t is defined, let me write it first. It is 0 to infinity e power minus st into f of t dt. This is the definition of Laplace transform. Now we are interested in Laplace transform of t power n. Okay, so just replace f of t by t power n. Okay, so 0 to infinity e power minus st, and your f of t is t power n. T power n dt. Okay. Now you need to integrate it by parts. So if you don't know by parts, then look at this by parts. Integration of uv with respect to, if it is dx, so first function integration of second minus integration of second into derivative of first. Okay, so this way you can integrate. And you have to remember that Eilate expansion, that is Eilate method, first function is treated to be according to this rule. Whichever comes first in this. I means inverse trigonometric, L means logarithmic, A means algebraic, and T means trigonometric, E means exponential. Whichever function comes first according to this word, so you have to treat that as a first function. So here t power n is, it's algebraic, and E exponential. So this is treated as second function. So let me write it first. I can rewrite it. T power n into e power minus st dt for your better understanding. Now this is your u. This is of the form u into v dt. Okay, so t power n is u and e power minus st is v. So by parts, first function, that is t power n as it is, into integration of second. Integration of second is e power minus st by minus s. Integration of e power ax is e power ax. Remember this. Integration of e power at with respect to t is e power at by a. Okay. So next, minus under the integral sign you have to write as it is, integration of second, that is e power minus st by minus s into derivative of first, derivative of t power n. Derivative of t power n is n into t power n minus 1, like how a derivative of x square x power n is n x power n minus 1. In the same way, derivative of t power n is n into t power n minus n into dt, and the limits 0 to infinity. 0 to infinity. Here also you have to apply the limits 0 to infinity. Okay. Now if you put upper limit, that is t power as a t as a infinity, it becomes e power minus infinity. E power minus infinity means 1 by e power infinity. 1 by e power infinity is infinity. So this also infinity and its denominator is also infinity. It takes the form infinity by infinity, and if you evaluate by L'Hospital's rule, it becomes 0. So direct you can keep first term as, on substitution of e power infinity 0, it becomes. Similarly, if you put lower limit t as 0, so this term into this is going to be 0. So entire this first part is going to be 0. Next, this minus into minus you can write plus 1 by s 0 to infinity e power minus st. N I can take also outside, it's n by s you can write, okay, into t power n minus 1 dt. This is what? This is your, let me write here down, this is L of t power n is what you got, n by s 0 to infinity e power minus st into t power n minus 1 dt. Okay, call it as equation 1. Now we need to write general result. So for that reason you have to use this repetitively. So using this repeatedly, so what happens here? This is L of t power n is this much. So what is L of t power n minus 1 then? Because I want this. Okay, so L of t power n minus 1 is, or let me write first, let me write it in the more general form. This is n by s, and according to the definition of Laplace transform, okay, this resembles the Laplace transform of this. So by the definition of Laplace transform, this can be written as L of t power n minus 1. I can call it as 1. Okay, so this is your L of t power n. Now you have to find what is L of t power n minus 1 using this relation. So using this, what is L of t power n minus 1? According to this, L of t power n is n by s. So L of t power n minus 1 is n minus 1 by s into Laplace transform of t power n minus 2. Like how t power n you are getting t power n minus 1. So Laplace transform of t power n minus 1 is t power n minus 2. Similarly, continue this. What is L of t power n minus 2? So you'll get n minus 2 by s into L of t power n minus 3. It continues like this. T power n minus 3 L of t power n minus 3 is n minus 3 by s into L of t power n minus 4. So this continues, and suppose L of t square, according to this you will get 2 by s L of t power 2 minus 1, that is t power 1. L of t then is 1 by s L of t power 0. So which is equals to 1 by s L of 1. So we know that Laplace transform of 1 is 1 by s. So we'll get 1 by s into 1 by s. So remember this. Now we have to substitute all these in this expression. Okay, you know this is this much and this is nothing but this much. So you have to back substitute all these in 1. So by back substitution, okay, L of t power n is equal to, okay, we had n of s, look here, n by s into this much, and this is nothing but we have here. Okay, so it is n minus 1 by s, and again L of t power n minus 2 is n minus 2 by s, n minus 3 by s into, it continues like this, and you will end up with this. You will end up with L of t power 1. So that is 1 by, look here, what we had, 2 by s into L of t. L of t is this much, 1 by s into 1 by s. Okay, so like this you will get, and look at this. So how many terms are there? There are in the denominator, look, s is multiplied how many times? It is multiplied n plus 1 number of times. Okay, so from here to here it is n number of times, and there is one extra 1s. Look here, 1 2 3 up to n we have. So numerator is n factorial divided by s is multiplied n plus 1 number of times. So s power n plus 1. So this is your Laplace transform of t power n when n is integer. Okay, remember this. Whenever n is positive integer, this is the Laplace transform. Now one thing to be noted, when n is any constant, when it is not an integer, we have another expression in terms of gamma function. Okay, so just note on this. If n is not an positive integer, if m is not a positive integer, or no, n is any constant. So we know that this you study in beta gamma function. Gamma n plus 1 is equal to n factorial. Okay, this is the notation for gamma n plus 1. So So n factorial is equal to gamma n plus 1. And also let me tell you the definition for gamma function that you studied in beta gamma function, but let me tell you, gamma n is 0 to infinity e power minus x into x power n minus 1 dx. This is the definition for original definition for gamma function. So we can write this also. What we had already, we had this, sorry, s power n plus 1. We have this gamma, that's Laplace transform of t power n is n factorial by s power n plus 1, and n factorial is nothing but in terms of gamma n, it can be written as gamma n plus 1 by s power n plus 1. So there are so many properties for gamma function, so you remember this. Laplace transform of t power n is n factorial by s power n plus 1 or gamma n plus 1 by s power n plus 1. So when you do some examples, you will understand better. Okay. Now here, for example, L of t cube, Laplace transform of t cube. Here 3 is a positive integer, you can write n factorial, that's 3 factorial by s power 3 plus 1. That is 3 factorial divided by s power 4. Similarly, L of t power 7 can be written as 7 factorial by s power 7 plus 1, 7 factorial by s power 8. So L of t power half. Now you cannot write it as a half factorial. So we have to write in terms of gamma. It is gamma n plus 1, that is half plus 1 by s power half plus 1. So it's gamma 3 by 2 by s power 3 by 2. And we have the value for gamma 3 by 2. Okay, so we will be studying it. So remember that whenever n is not an integer, positive integer, if something constant, you have to express in terms of gamma function. Okay, similarly, if you have L of t power 3 by 2, then you can write it as gamma 3 by 2 plus 1 divided by s power 3 by 2 plus 1. That gives you gamma 5 by 2 by s power 5 by 2. Okay, as the time proceeds, you will understand better. Okay, so now we'll be dealing with some basic examples. Okay, now see here, find Laplace transform of sin 2t into cos t, cos 3t into cos 2t. Okay, like this they will ask. Now we know the Laplace transform of individuals, sine and cos. So whenever there is a product, you have to express it as a sum by using transformation formula. Okay. Now see here, we want L of this. sine 2t into cos t. Okay. Now see here, you need to express this product as a sum. So use this sine A into cos B formula. Sine A into cos B is 1 by 2 sine of A plus B plus sine of A minus B. So you remember this. So if you use that 1 by 2 outside, L of, okay, A is 2t, B is t here. So what will get? Sine A plus B, that is 2t plus t, plus sine A minus B, 2t minus t. Okay. This is half Laplace transform of sine 3t. So 2t minus t is 1t. And I had given you what is Laplace transform of sine at. It is a by s square plus a square. So you can write 3 divided by s square plus 3 square. Similarly, Laplace transform of sine t, here a is 1. So you can write 1 by s square plus 1 square. Okay, remember this. Laplace transform of sine at is a by s square plus a square. Okay. So if you want, you can simplify, otherwise not necessary. Similarly, go for this cos 3t into cos 2t. Okay. So let's have second one, L of cos 3t into cos 2t. Okay, again you need transformation formula converting product into sum. So let me write that cos A cos B is equals to 1 by 2 cos of A plus B plus cos of A minus B. Remember this. Okay. So according to this, this becomes 1 by 2 L of, okay, so A is 3t, B is 2t, cos of 3t plus 2t is 5t, plus cos of 3t minus 2t is t. Okay. This is 1 by 2 L of cos 5t, you can write directly. Laplace transform of cos 8 is s by. So s by s square plus 5 square, s by s square plus 1 square. Okay. So remember this. Laplace transform of cos 80 is s by is s by s square plus s square. Okay. So remember this. Whenever you will get a product, you need to convert it as a sum and then apply individual Laplace transform. Let's have one more. Find Laplace transform of cos t into cos 2t into cos 3t. Similarly, sin t sin 2t into sin 3t. Okay, product of three terms. Again, you need to convert it as a sum and then apply Laplace transform. Okay. So first one, L of sin t, that is cos t, cos 2t into cos 3t. Okay. Now you need to make a group of two terms. So I can write it as, first I write term with bigger angle inside, cos 3t into, because that helps in some way. I can rewrite it, cos 3t into cos 2t into cos t. L of cos 3t as it is, apply transformation formula for this. As I mentioned earlier, cos A into cos B, it is 1 by 2 cos of A plus B, that is 2t plus t is 3t. Next, plus cos of A minus B, that's 2t minus t is t, that we done earlier. Okay. Now take 1 by 2 outside. Now multiply this into this, cos 3t into cos 3t. Either you can cos square or cos into cos you can write. So for your understanding, I can write cos square 3t, or you can write cos 3t into cos 3t, doesn't matter. Cos 3t into cos t. Okay, this into this. Reapply the transformation formula. Okay. Now see here, cos square means cos into cos. There are two ways. One can write directly. If you don't know this, you can write this, cos square theta is 1 plus cos 2 theta by 2. Remember this. Otherwise, you can write cos into cos and apply the same transformation formula. Okay. So now see here, if you don't remember this, you can write it as cos 3t into cos 3t, doesn't matter. And this is cos 3t into cos 2t as it is. So use the transformation formula for this. 1 by 2. Okay, cos A plus B, that is cos of 6t, you will get double of that. Cos of 3t minus 3t is cos 0, you will get. Plus transformation formula here. So again, half cos of 4t, 3t minus t is 2t, cos of 2t. Okay. Even if you use, we will get the same thing, because cos 0 is here 0. It is 0. Okay, 3t minus 3t is 0. So cos 0 is 1. So take 1 by 2 outside. So 1 by 2 into 1 by 2 you will get. Already 1 by 2 is there. And inside you will left with L of cos 60. Cos 0 is 1. Cos 40 plus cos 2t. Okay. So 1 by 2 into 1 by 2 is 1 by 4. Now apply Laplace transform. Okay. Laplace transform cos 6t, s by s square plus 6 square. one can write directly 36. Laplace transform of any constant. Okay, remember this. Laplace transform of A is A by S. So similarly, Laplace transform of 1 is 1 by S. Plus Laplace transform of cos 40. S by S square plus 4 square. And Laplace transform of cos 2 is S by S square plus 2 square. No need to simplify further. So this is the Laplace transform of given product. Okay. Let's look at the next example in terms of sine. So you are asked Laplace transform of sine. So L of sine t into sine 2t into sine 3t. So rewrite it as L of sine 3t into sine 2t into sine t. So use the transformation formula. Remember this, sine into sine. Sine A into sine B is, remember this, it's minus 1 by 2 cos of A plus B into, that's minus cos of A minus B. Remember this formula. So using that, it's L of sine 3t into half, okay, cos of A plus B. 2t plus t is 3t. It is cos of 3t minus 2t minus t is 1t. Cos of t. Remember this. Now take 1 by 2 outside and L of, get multiply this into this. Sine 3t into cos 3t minus sine 3t into cos t. So again you got sine into cos. So use that transformation formula that I had given earlier. It's 1 by 2 L of, okay, sine A cos B. So 1 by 2 sine A plus B. That is sine of 60 plus sine of A minus B. That is 3t minus 3t is 0. Sine 0 you will get. Minus 1 by 2, same thing. 3t plus t is 4t. Sine of 3t minus t is 2t. So please remember the very first transformation formula, sine into cos. As earlier, bring this 1 by 2 outside, 1 by 2. So 1 by 4 you will get, directly you can write, into L of sine 60, sine 0 is 0, minus sine 40, plus into minus minus, sine 2t. Okay. Now apply the Laplace transform. It's 1 by 4 Laplace transform sine 60. Sine 80 is what? A by. So it starts with 6 by s square plus 6 square Laplace transform of sine 4t. Again it is 4 divided by s square plus 6 square, that's 4 square, minus 2 divided by s square plus 2 square, because we used this. L of sine 80 is what? A by s square plus a square. Okay. So in this way, if you get product, convert into sum or difference. Okay. So let's have, if we get square term, then how it can be done. Because we get often such situations. Find Laplace transform of sine square 3t cos square 2t. Okay. So as I mentioned, if you get square, there are direct formulas for this. Otherwise, you can convert sine into sine, cos into cos, and apply transformation formula. Both the options are with you. Okay. So L of sine square 3t. There are two options. One, you can write sine into sine and use the transformation formula sine A sine B. Otherwise, better you remember every time, don't apply transformation formula, and simplified version is this. Sine square theta can be written as, it's a 1 minus cos 2 theta by 2. That is same transformation formula. If you write sine into sine, you will get the same thing. Similarly, if you get cos square theta can be written as 1 plus cos 2 theta by 2. Remember these two very important formulas, we often get these. Okay. So it's 1 by 2 L of 1 minus cos of double of this. Double of 3t is 60. Okay, using this formula. 1 by 2 outside, 1 minus cos of double of this. So directly you can write 1 by 2. Laplace transform of 1 is 1 by s. Laplace transform of cos is s by s square plus 6 square. You can write directly 36 or 6 square. Okay. So similarly, try the second one. Laplace transform of cos square 2t. As I mentioned earlier, cos square can be written as, it's 1 by 2 1 plus cos double of this. Here cos square theta means 1 plus cos 2 theta. So double of 40, 2t is 40. So 1 by 2, Laplace transform of 1 is 1 by s. Laplace transform of cos is s by s square plus 4 square. Okay, so in this way you can apply Laplace transform for some common functions. So in the next class we will be doing few more examples. So keep watching and keep sharing with your friends.